Hi everyone. Today we are going to learn about a very important concept called as centroid. So let me first give you the definition of centroid. So the centroid is a point in the figure or object at which the whole of the length, area or volume of the figure may be assumed to be concentrated. So basically the centroid is a point in the given object or figure at which we can assume that the length of the object or area of the object or the volume of the object is concentrated. So let's understand this with the help of an example. If you see this particular object, it is a linear object, so it has got certain length. Now if I wanted to find out a point at which we can balance the entire length, so the point is going to be at somewhere in the middle of the length. So this is the center point of the length. So this is called as the centroid of this particular object, which is a linear object. So this is called as centroid of this particular object. Now if you take another object, friends, this object has certain area over here. Now if I want to find the center point of this object or this area of the object, the center point is going to come somewhere over here. So this point we can assume as a centroid, and we can assume that it is balancing entire area of this object is concentrated at this particular point. So this can be called as the centroid of this plate. So this I can call as C. C stands for centroid. Now let me take another object which is a three-dimensional object. So in this object we would like to find a point at which the entire volume is getting balanced, or at which entire volume of the object can be assumed to be concentrated. So I'll find out the center point of the entire volume, and that is going to come somewhere here, as you can see. So this is going to be the centroid of this particular three-dimensional object. Okay. So from these three examples, now we can easily conclude that center point is the center of the length or center of the area, and for that matter it is center of the volume of the given object. So we can also define the centroid is the center point of the length, area or volume of the given object. Now we'll do some examples to understand how to find the centroid of a given object. So I'm going to first explain you the process to find out the centroid of a plane figure. So we'll take a plane figure over here, for instance. So let me first define the reference axis. So I have taken x-axis as a horizontal and y-axis as a vertical axis, and with reference to these two axes I'm going to define the position of this particular object. So there will be certain point in this plane object. This point I'm going to call it a centroid. So this is the point which is center of the entire area of this object, I can say. So we are interested to find out the coordinate of this particular point C, that is called as the centroid of the plane figure. So its coordinate is given by x bar, and then with respect to x-axis is given as y bar. So if you can find out x bar and y bar for the given plane object, it means you can find out the centroid of the given object. Okay. Now what is the procedure to find centroid? So we will take a small area here, dA, and this area dA is very small or infinitesimally small area. I can say this is a small area, friends. Okay, and we find out its location with respect to y and x axis. So from y axis it is at distance x, and from x axis it is at distance y. So I have taken a very small area or infinitesimally small area in the given plane object, and I have found out its location with respect to x and y axis. So we have to find the coordinate of centroid of given plane object, this plane object, friends, and for that we have got an expression. So this is called as x coordinate of centroid. So x coordinate of centroid is given by integration of x dA divided by integration of dA. Now this is very important point to remember here, friends. This is basically first moment of area. This is called as first moment of area. We are multiplying by distance, so it is first moment of area. So whatever small area we have taken, we will find out its moment with respect to y-axis, that is x times dA. So this is called as first moment of area. Okay, and we'll integrate that because this similar small area can be taken throughout the surface of the plane object. So that is why I have taken the integration of it, and that we have divided by the integration of dA. So when I divide the integration of dA, this means it is the entire area I am going to get, because if I take small area on the entire surface and I will integrate, it will give me the entire area of the surface of the plane. Okay, so that is what I have got here, friends. So integration of small area, we got the total area of the plane figure, and then in the numerator again the same value will stand, that is integration of x dA. In the similar way, I can also find out the y coordinate of centroid, that is first moment of the area with respect to the x-axis. Here you can see, so dA times y, and I have integrated that divided by integration of small areas over the entire plane. If I simplify, I will be getting, friends, integration of y times dA over total area of the plate or total area of the plane. So here I have already told you, friends, A stands for the total area of the plane. Now this is the procedure I am going to follow to find the x coordinate and y coordinate of the given plane object. Now we will do some examples and we'll find out the exact expression of the centroid of plane figure. So let's see, friends. Here I am going to find out centroid of a triangle. So we have to find the location of the centroid of a triangle with respect to its base. Let me show you the figure, friends. So I have got a triangle PQR over here, and with respect to base of this particular triangle, we are interested to find out the location of centroid. So before that, let me tell you that height of the triangle is h. So from here to base, the height is h, and the length of the base is basically b. Let me show the reference axis over here, that is important. So I have shown x-axis and y-axis. So x-axis is passing through the base of the triangle. So if you look at the figure, friends, the area towards the base is more. So you'll be seeing that the centroid will be shifted towards the base somewhere over here, friend. Okay. So this is the location of centroid, we can say, and we are interested to find out the distance of the centroid from the base of the triangle, that is y bar. Okay. Now how to find the y bar? That is very important. To find the centroid of this triangle, I am going to consider a thin strip of thickness dy. So I have taken a thin strip having thickness dy and length L. So length of the strip is going to be L, and its distance from the axis is going to be y. Okay. So I have got a thin strip over here, friends, whose length is L and the thickness is dy, and its distance from the base of the triangle is taken as y. Now this thin strip is going to have small area. So the area of the thin strip is going to be very small. I can say dA. Since the thickness is very small, its area is also going to be very small, friends. So we got a very small area in the form of a thin strip, which is at distance y from the base of the triangle. Okay. So we can find the area dA as the product of length of the strip times thickness of the strip, that is dy. That is very clear from diagram itself. The length is going to be L and the thickness is going to be dy. So it is approximately like a rectangle, and the area is going to be dA, that is L times dy, friends. Okay. So if you see in the diagram, friends, this distance, that is from strip to the tip of the triangle, is going to be h minus y. H minus y because the overall height is h, and from here to here the length is y. This dy is very small, so I have neglected it. So I have directly calculated the value of this distance as h minus y. So friends, we know that the y coordinate of centroid, that is y bar, is given as, already we have discussed, y bar as what? Integration of y times dA divided by integration of dA. Okay, so from here you can find out the y bar. Okay, so now let me put the values here, friends. Now this is integration, friends. Now y, the value of y will be as it is, and the dA we have to put. So dA already we have got it as L into dy, and that is divided by, this is basically area of triangle, friends. You can write down here area of triangle. So here, in order to find the value of y bar, we need to substitute the value of L over here. So we need to find out the length of the strip. So here if you see the triangle over here, friends, so from simple geometry I can write down L divided by B will be equal to h minus y divided by h. This is by simple geometry we can get this outcome, friends, because if you see there is a small triangle over here having base L, and there is a big triangle over here having base B. So L by B will be h minus y divided by entire value, the entire height h. So from this expression, I will substitute the value of L in this equation, friends. So let's see what we will get here. So we will be getting y bar equal to integration of y as it is. L will be B by h, h minus y. So we got the value of L, friend, now into dy. So this is the numerator we got. Now denominator is basically the area of the triangle, and that is nothing but half into base into height. So base is B here and height is h, friends. So if you look at here, the base is B and height is h. So the area of triangle is going to be half times base into h. Now we'll simplify this and integrate. Now if you see here, friend, in the numerator and denominator we have got b. So b will be cancelled out. B is a constant, it cancel out. So here you'll be getting 2 by h square integration of yh minus y square dy. Now if you look at here in this figure, friends, we are going to integrate this quantity from the bottom of the triangle to the tip of the triangle. So at the bottom of the triangle, friends, the value of y is going to be 0 here, and at tip of the triangle the value of y is going to be h. So we shall be integrating accordingly from y equal to 0 to y equal to h. We will have this limit. So let's see what you will get in this case now. So we'll be getting y bar as 2 by h square. Now here integration of yh is going to be y square h by 2, and the integration of y square is going to be y cube by 3, friends. So it is going to be y square y cube by 3. The integration of y square is y cube by 3 over here, and the limit will be from y equal to 0 to y equal to h. So here I am going to put h for y, means at the place of y I am going to put h. So it is going to be h square into h, that is h cube by 2, and this is going to be h cube by 3. So h cube by 2 minus h cube by 3 is going to be h cube by 6. If I simplify this, friends, I will be getting 2 divided by h square into cube by 6, that will be equal to h by 3. So therefore we got the y coordinate of the centroid as h by 3, that is height of triangle divided by 3. So this is the expression for centroid of a triangle with respect to its base. So this y bar is going to be, friends, h by 3, like this. So like this we can derive the expression of centroid of a plane figure such as a triangle. We will see some more examples in similar way. Thank you very much.